just this week I've been asked, what does this vellum rest blend sub do? And frankly, I must admit that I didn't even have a clue that this node existed at all. So I had a look at it, and here's my take on it. So to demonstrate what it does, just for now, let's drop down a sphere, dive in there, set the sphere to be a polygon, maybe increase the frequency to say 8. Let's attach to this a mountain to just distort this sphere a bit. Something like this for now, just a short and brief demo like this. To this mountain, let's attach a null, call this one out_mountain. Now let's set up our cloth sim using a vellum configure cloth, wiring in the sphere in here. And to this, let's attach a vellum solver, highlight it, and in here, let's just disable the gravity, set that to 0 like that. And also maybe in the solver, let's just decrease the constraint iterations to say 16 like this, and just hit play. And we see nothing really happening here, as expected. So let's, in between the vellum cloth and the vellum solver, wire in a vellum rest blend. Like this, you can see these first 3 lines snap to the first 3 points here, and into the 4th point here, I wire in my mountain here. And within the vellum rest blend, I can by default set a blend value here, which when set to 1, and let's just let this run, will immediately drag out the corresponding points on my input mesh, the sphere, to the points on my mountain mesh here. I can also set this node to blend by a distance value, so when I set this to something rather small like this, we can see only points close by get drawn a bit to the mountain shape here. Let's set this back to blend and try animating this blend from 0, so it does nothing, to 1, so it pulls it out. So let's say go to frame 12, set a keyframe there, and then to frame 36, set this to 1, keyframe it, reset our simulation and simulate this. And we can see nothing is happening here, because this vellum rest blend gets only evaluated once as it's fed into the solver here. So what if you want to animate your blends here? Well, as always, there are several ways of doing that. Let's just delete this one here and reset our scene, and dive into this vellum solver here. Within this forces tab in the vellum solver, we can also drop down a vellum rest blend here and wire this in our force output tab here. However, now we need to specify a source, which we'll set to a sub here, and this will point to our out_mountain null here. And now all I have to do is set my update frequency to each frame or each substep to my liking, and then I can animate this blend value here. So again, I'll just go to frame 12, set this to a blend value of 0, go to frame 36, set this to a blend value of 1, again keyframe it, and then reset my whole scene, head up 1 level, and hit play. And now I get this animated version of my blend. However, what if I want to animate between different blend shapes, not only these rest and mountain substates here? So for example, let's add another state, call this one out_, let's call it stretched. To this, wire in a transform, and the sphere goes into the transform, and let's just scale this sphere along the x-axis, so we get something a bit like that. Zoom out a bit, like this. Clearly, when I dive back into my vellum solver, within the vellum rest blend, there's only one source sub. So how do I go about this? Well, I can use one of Houdini's blend nodes. One will be the blend shapes, which allows me to wire in different geostreams here. And then here in this blend shape node, by going down here and clicking update channel names from input, let's just highlight this one here. I get this single slider that allows me to blend between those individual states. Let's just wire in our non-distorted sphere as well, and just set this to the first input slot, and again click update channel names from inputs, so I can now blend between my sphere and my mountain. And then you can see there's something weird happening, because we're now trying to mix the 2 states between mountain and transform, and that's a bit awkward because I'd have to animate multiple sliders in order to cleanly go through this blend shape sequence here. Luckily, there's also the sequence blend, which allows me to do all this just using one single slider. So I'll wire in the sphere first, then the mountain, and then the distorted one here, highlight the sequence blend, and now I can just drag this input blend over between 0 and 2, and we will seamlessly blend between all those states. Let's just attach a null to this one again, call this one out_sequence blend, goes in here, and then let's dive back into our vellum solver and set our subpath to this newly created out sequence blend here. And let's just get rid of our keyframe animation here and just set the blend mode to 1. Because now what we can do is, while we are running the simulation here, we can animate just this input blend value here, and the simulation will automatically look up the corresponding blend shape. So let's just run the simulation, and while it's running, I can manually drag the slider up here, and in somewhat interactive real time, get the result here in my viewport. So that's the bare theory, but let's build something at least a tiny bit more useful. And let's start with a new file here, in which I'll drop down a grid, dive in there, resize this to maybe 2 by 2 units and have 200 by 200 rows and columns. And now what I'd like to do is kind of emboss letters onto this grid. And as I'm rather lazy and not very clever, I'll just use the brute force way of dropping down a font sop here, then just typing something like, for example, let's start with a B. Also, this one needs to be transformed so it sits in the same plane as my grid, like this. And let's move it down a bit. And to this, attach a poly extrude, which we'll use to extrude this font. Let's check output back to, and drop down a group node, wire in the grid on the one hand, and the extrusion on the other. Dive into this group node here, set it to points, call the group move, and for grouping this, let's uncheck the base group and check keep in bounding regions, set to bounding object. So we now have only points within that B selected. Next, we'll drop down another transform, set this to only affect the move group, and then translate the move group up a bit, like 0.15 units. The only thing that I dislike about this is this hard edge here, so let's use an attrib blur, set to P for position, wire our mesh in here, and increase the blurring iterations a bit, so we blur out these edges here so they flow into each other like this. So we've got our first letter here, our first blend shape. Let's just take all this here, copy and paste it, do this for another letter, this one maybe A. Again, copy, paste it, change our letter to M, and finally, for good measure, add an exclamation mark. So we have now our blend shapes for B, A, M, and an exclamation mark, as well as our standard grid, which of course, instead of copying this, we could wire this to the same grid. So if we change the grid's resolution, it'll automatically propagate to all the blend shapes, because blend shapes need to have identical point count, so the algorithm can blend between them, like this. Next, attach our sequence blend, and the first thing that goes in here is the unmodified grid. Let's just by alt-clicking on the connection line here, add a few in-between points, and then add these other modified geometries in here too, and let's highlight the sequence blend, and when we scroll through this input blend value here, we can see we get our B, A, M, and our exclamation mark, like that. Let's just keyframe this, starting at frame 12, going all the way to maybe frame 96, to a 4 here. So when we enable real-time toggle, we can hit play, and we see our B, A, M, and exclamation mark appearing. And again, this is just lazy keyframing. I could tweak the animation to my liking. Let's just briefly save this, and set up our vellum simulation. Again, dropping down a vellum cloth, wiring in our grid, and then directly attaching our vellum solver. In here, again, let's decrease the constraint iterations to 10, maybe increase the substeps to 2, and disable our gravity. So our cloth here floats by default. Then back into the solver here, and let's drop down our vellum rest blend, wire this into force output, and then point it to a sop, which let's just head up again. I haven't added a null here, so let's make it easy for us. Call this one out. Blend, sequence, attach it, and back into our vellum solver. Let's point the vellum rest blend to that null we just created. Set the update frequency to each substep, head up again. Let's highlight our vellum solver, save this, keep our fingers crossed, and hit play. And although my cloth looks a bit too wavy for my taste, you can see basically our setup already works. So let's just dial in a few values here. For example, in our vellum cloth, we can increase the drag, the normal drag to 100 and the tangent drag to, say, 10, and just resimulate this. And although this still might need a bit more drag, I think you get the idea. Again, we can tweak our damping values here on the normal drag and tangent drag, and we're using this sequence blend with all those individual blend shapes to drive our vellum rest blend that resides within our vellum cloth solver here. So those are the basics of the vellum rest blend node.